A very good morning to one and all. Our topic for the assignment is 2D parity check. But before going straight to the topic, let me explain you about the error detection code and various error detection techniques. And finally, let us know about the 2D parity check. Now what is an error? A condition when the receiver's information doesn't match with the sender's information is basically an error. What happens during transmission is that the digital signal suffer from the noise that can introduce error in the binary bit traveling from sender to the receiver. This means that 0 bit may change to 1 and 1 bit may change to 0. Now, to know whether there is error or not, there are error detecting codes. Whenever a message is transmitted, it may be scrambled by noise or data may get corrupted. To avoid this, we use error detecting codes, which are additional data to the given digital message to help us detect if any error occurred during the transmission of the message. Now, there are various error detecting techniques. The most popular error detecting techniques are the single parity check, two-dimensional parity check, checksum, and the cyclic redundancy check. But our topic is mainly based on 2D parity check. But before knowing what is 2D parity check, we need to know about the simple parity check. Now, what happens in simple parity check? In this, 1 is added to the block, that is the data, if it contains odd number of ones, and 0 is added if it contains even number of ones. Now, for example, in the below diagram, the data contains 3 ones, which is odd. To make it even, the parity bit that is added is 1. And after adding the parity bit, the data is transmitted. If there are even number of ones, then the parity bit added will be 0. This scheme makes the total number of ones even. So this scheme is also called as the even parity checking. Now let us know about the two-dimensional parity check. Parity check bits are calculated for each row, which is equivalent to simple parity check bit. Parity check bit are also calculated for all the columns. Then both are set along with the data. At the receiving end, these are compared with the parity bits calculated on the received data. This is how the 2D parity check actually works. In the below diagram, as you can see, for each row a parity bit is added, and also for each column a parity bit is added. And then the data is transmitted. Now we have written a program to accept a set of data words and implement 2D parity checking, which will be explained by two of my friends, and further which will be continued by the advantages and the drawbacks of 2D parity check.
I am going to explain how error in only single bit can be detected in 2D parity checking. We can exactly find the position of the error in the bit, hence it can be corrected. In this code, an error is added at a random position in the data. Now let us run this code and check. This is the original data, and this is the data after adding parity bits. Now our code adds an error at line 3 and character 3 that will be at this position. After adding an error, our data will be this, that 0 will be converted into 1, and in the receiving end the error is caught by comparing the parity bit. Let me explain. At the receiving end, the number of ones in the column 3 is odd and the parity bit is 0. Hence there is an error in this column, and also the number of ones in row 3 is odd and the parity bit is 0. So there is an error in this row. Hence we can find out that intersection of this row and column will give us that there is an error in line 3 and character 3. This is one of the advantage of 2D parity checking. Thank you.
The program first starts with asking the user the total number of messages and the length of each message. Let us take an example of 3 total number of messages and 3 is the length of each message. Then we initialize our array with this data. We use random elements. We set the seed to current time and then generate random elements, random zeros and ones, and then fill it into the array. After that, we just print the elements. So this is the original data, and then we add a parity bit to each row and column. A parity bit is if the number of ones in a row is even, we add a 0, and if the number of ones is odd, we add a 1. So the function works as we first traverse through the complete row and then also count the number of ones in the row. And then we use the mod operator to find out if the number of ones was even or odd. If it was even, we add a 0, else we add a 1 to the parity bit. Same goes for the column. After 1 1 0 1 1 and 1 1. After that, we check for the error in data in the program. So the check error methods functions the same way. We first calculate the parity bit by ourselves in this method by first traversing over the row, and then if the parity bit which we currently calculate does not match the parity bit which was sent, it is an error and we flag it. This was for the row and same goes for the column.
There are two major disadvantages that comes with two-dimensional parity check technique. First is addition of extra bits. Whenever we need to perform 2D parity check, we need to add some of the parity bits. These bits also needed to be transmitted. So let us see with an example. Suppose we have 5 strings with 5 characters each. Here we need to add 11 parity bits which are to be sent along with the data. So it is evident more is the number of data bits, more will be the parity bits, hence more burden will be there. And the second disadvantage is that these checks are not very efficient. In some of the cases, no error is found by this technique even though a data has been manipulated. So we have created a function induce error exception method. Here there are two loops I and j which corresponds to traversing in rows, while k and l which helps in traversing in columns. Our aim is to find intersection of these two rows and two columns in such a way that their data bit is same. Then we are able to invert those data bits and successfully able to produce such an error that two-dimensional parity bit checking fails. Now let us understand it. We will proceed with undetectable error. Here we have induced error at line 1, character 1, line 1, character 2, 1 1. Similarly with line 2, character 1, line 2, character 2. So it has been changed from 0 0 to 1 1, and same thing happens in second line. It is changed from 0 0 to 1 1. Now we pass this data again to 2D parity check technique and no error is found because there are even number of ones where needed. So these are the two major disadvantages of two-dimensional parity checking technique.